P orbitals, we have done that. Relate atomic numbers of the position of an element of the periodic table. Yes. Also, by virtue of this, that has atomic number of what? 2, 7, as in 9. So 2, 7. So automatically this atom will definitely be a group 7 element, because elements are placed in group based on the valence or outermost electron. And since the outermost electron here is 7, this element will definitely be what? A group 7 element. Then period. Then this element will be in period 2, simply because elements are placed in period based on the number of shells. So see how many shells do we have? K and L. Then you have 2 shells. That is why it will definitely be what? In period 2. Relate properties of groups of elements on the periodic table. So you are relating that. Then we'll be talking about atomic radius, ionic radius, ionization energy, electron affinity, electronegativity, which we are going to talk about elaborately in the subsequent slide. So the properties of groups of elements on the periodic table. We have periodic table, we have periodic law, then we have atomic / ionic radius or radii, then we have ionization energy, then we have electron affinity, we have electronegativity. The way they behave down the group and across properties across the period. First and foremost, periodic table is talking about the groups and period to which element belongs with respect to their what? Atomic number. It's the atomic number that determines the group and period to which an element belongs. So elements of the same group will definitely exhibit the same properties. Now, periodic law. Periodic law states that the properties of elements are the periodic functions of their atomic numbers. What that simply means is that it's the atomic numbers that determines what? The properties of elements. So let's talk about the properties of groups of elements on the periodic table. So in this situation, we're talking about atomic radius and ionic radius, ionization energy, electron affinity, then electronegativity. Let's talk about atomic radius. Atomic radius down the group. Atomic radius is definitely the distance between the positively charged nucleus and the electron, which is negatively charged, revolving around the orbit. Now, atomic radius, how does it respond down the group? As you move down the group, what happens to the size? As you move down the group, the number of shells increases. That means the distance between the positively charged nucleus and the what? Electron increases. And what happens in that regard is that since a number of shells is a measure of the what? Atomic number. Because as the atomic number increases, as you go down the group, atomic number increases. Therefore, the number of shells increases. So automatically, atomic radius will definitely what? Increase. It increases down the group. It increases down the group. Across the period, down the group, where you have sodium, let's say lithium, which is 2,1, sodium, let me put it like this, lithium, sodium, 281, potassium, 2881, rubidium. So as you are going down, the number of shells will definitely increase. That is why it increases down the group. But across the period where you are having, let's say lithium, that's 2,1, beryllium, which is 2,2, boron, 2,3, carbon, 2,4. So as you are moving across the period, what happens? There is additional electron. So what happens is that as you are adding protons, you are also adding electrons simultaneously. So what happens to the size? Then there will be what? A contraction. Because this distance between the positively charged nucleus and the electron becomes what? Closer or smaller. So, and therefore, the distance is now what? Shorter. So automatically, what it means is that as we are moving across the period, the fact that proton is added, you can see that 1 plus this 2, 1 plus 2, 3, 1 plus, so there is a continuous addition of what? Electron. And as you are adding electron, you are adding proton simultaneously, since electron is a measure of what? Proton. So automatically, what happens to there will be a contraction as a result of what? Increase in nuclear charge. So what happens there is that there will be a decrease. It will decrease. It decreases across the period. So that is the deduction as far as atomic radius and ionic radius is concerned. Next topic is nuclear chemistry. First and foremost, we have radioactivity. Radioactivity, I'll be talking about radioactivity, especially the elementary treatment only, then nuclear reactions, simple equations, uses, application of natural and artificial radioactivity. Objectives. Candidates should be able to distinguish between ordinary chemical reaction and nuclear reaction. And what is the difference between ordinary chemical reaction and nuclear reaction? We talk about chemical reaction. It has to do with the combination of two substances of two or more substances that are known as reactants to form products. But in this aspect, that is the ordinary chemical reaction, some factors, external agencies, affect the rate of reaction, such as temperature, pressure. But in nuclear reaction, these are reactions that occur spontaneously, and there is what? A disintegration. Most especially, we use those substances that are unstable, and in no distant time they disintegrate. So the major difference between chemical reaction and nuclear reaction is that in chemical reaction, the rate of reaction is usually determined by the concentration of the reactant. If the reactants are highly concentrated, the rate of reaction will be very fast. And also catalysts can also speed up the rate of reactions. So what it simply means is that reactants are used up, and the products are being formed. And they are dependent on some factors such as what? Temperature, catalyst, pressure. But in the case of nuclear reaction is independent of temperature and also independent of catalyst. Nuclear reactions are unstable, whereas chemical reactions are stable. Also, we should be able to differentiate between natural and artificial radioactivity. First and foremost, what is a radioactivity? Radioactivity is a process that involves the spontaneous disintegration of a substance. It involves the spontaneous disintegration of a substance. So, in natural and artificial radiation, the major difference here is that in artificial radiation, radioactivity rather, the disintegration of substances is brought about by inducing the substance with neutron. to proceed, for the reaction to proceed. So there will be what? It does not occur spontaneously. There will be induction. You need to induce the substance of interest before the reaction can what? Proceed. But in the case of natural radioactivity, the disintegration of radioactive substance occurs spontaneously. So without external influence, it will readily occur. Also, I will also like to talk about half-life. And subsequently, we are going to be talking about the reaction, the calculation under this half-life. Half-life is simply the time taken. It's simply the time taken for half of the initial amount of a radioactive substance to decay. The half the initial amount to decay. So that is what half-life is talking about. Then subsequently, we are going to be talking about the calculation under half-life. Then also, under the nuclear reaction, we have nuclear fusion and nuclear fission. Mind the spelling. Fusion, fission. From the word fusion, it has to do with what? Coming together, fusion. While fission has to do with what? Splitting. So in nuclear fusion, this is the process by which two or more lighter nuclei combine together to form a large molecule with a release of energy. While nuclear fission involves the splitting of a heavy element into two nuclei of nearly equal masses with a release of energy and radiation. Take note of this.